Assalamualaikum warahmatullahi wabarakatuh. My name is MOHAMAD ZAINUL ARIFIN bin MOHD. My ID number is 2018259886. My supervisor is Dr. Hafizan bin Hashim. The title for my final year project is Bending Behavior of Square Tube with Multiple Transverse Cut. Firstly, introduction. The perfect crash would be none at all. However, with the ever-increasing demand for public transit, the possibility of an accident is always on the rise. According to WHO 2018 study on road traffic injury, each year approximately 1.3 million people lost their life in road traffic accidents. Between 20 and 50 million people sustain no fatal injury, with many developing disability as a result. The main purpose of this research is to create a support structure that can be used in automotive, and the structure can create or produce a perfect collapse. There are a few reasons why the transverse cut area has been chosen as an area to get a perfect collapse. The purpose beam should be as cost effective as possible. These need to be made from material that are easily to obtain yet still possesses necessary rigidity and collapsing ability. Due to this, my steel is selected for its appearance as well as ease of manufacturing and sustainable characteristics. Steel, in general, is also extremely environmentally friendly material due to steel being easily to recycle as well as not being toxic to both the environment and human. We can conclude that based on square tube with multiple transverse cut is the best solution to get perfect collapse. Nonetheless, if one is going to crash, one we want to have the highest chance of surviving possible, because surviving a crash is all about absorbing kinetic energy. As energy observed, tubular structure component of various shape and material has been widely used. When deforming under compressing in impact circumstances, they have the potential to collapse and transform huge amount of kinetic energy into plastic strain energy. As a result, there is an increasing interest in installing energy absorbing devices with greater capability to protect people from injury. Next, literature review. Under literal stress, bending collapse is significant energy disruption of mechanism for thin wall beams. Research have conducted numerous studies on the bending collapse of thin wall beams. Cashman proposed the first theoretical model for the pure bending collapse of rectangular section tube in 1983. Then, in 1994, Wizbicki used their traditional axial collapse theory to construct a hypothesis for bending collapse of rectangular beams. Following that, Kim and Reed improved catchment theory and found a closed-form solution for the bending moment. All of these theoretical models, however, can only scope pure, pure bending of thin wall beams. The problem with this structure design is that when a strong bending moment is applied, they are prone to localized plastic collapse due to their thin spall. In 2020, there are research on the bending collapse of multi-cell aluminum (CFRP) hybrid tubes. The purpose of this paper is to look into the bending collapse and crash worthiness of multi-cell aluminum or carbon fiber reinforced plastic hybrid tubes under quadratic and dynamic loads. Other than that, there are research on bending collapse modes of innovative sandwich panel with metallic foam core. Using the powder compact melting technology, a new approach was provided for the fabrication of aluminum foam-based sandwich panel with stainless steel wire mesh grid employed as a reinforced skin in this study. In addition, three-point bending tests were performed on multi-cell aluminum and innovative sandwich panel research. The Young modulus of a material in the shape of beam is measured using a three-point bending test. Next, problem statement. When tubular structure bend, they frequently experience deep bending collapse. The collapsing point is usually in the center of the tubes, also known as the Hitch line. Except for the Hitch line, the remaining part of the tube rotates as a rigid body during collapse. As a result, the majority of the tube parts are inefficiency at absorbing kinetic energy. Increasing number of loops could possibly increase energy exertion, so the efficiency energy exertion can be maximized. By using two transverse cut, we need to have threefold or point of bendings. Based on the preliminary analysis of the transverse cut on the model, it appears that there is only one fold on the model, and also the fold happened on the first cut, not the center of the bending. For this study, in order to get threefold bending, we need to manipulate or adjust the size and the location of transverse cut. Next is objective. Based on discuss of problem statement, there are few objectives that must be met in order for this study to be successful. First, to develop a square tube model with a few transverse cut using finite element analysis software known as Abacus. To analyze and optimize the amount of energy observation from the data that has been obtained from Abacus with the help of the MATLAB software. Third, to purpose multiply transverse cut to increase number of loops or folds, thus to improve the energy absorption capacity. Next, scope and limitation. First, to create three bending points and to make sure that the new loops that have been produced are in sequence. The variable that has been manipulated for multiply transverse cut are the location and size of the transverse cut. The material that we use in our project is mild steel. For my final year project, I need to conduct my study in a lab, but due to COVID-19 as it happened right now, my study will be conducted using MATLAB and Abacus software. Next is methodology. By using Abacus, a model was developed. A material was selected for the construction of model. In this case, MIT was selected. Initial runs was conduct to perform FEA analysis of the constructed model. One fold should appear in the initial test. After one fold was achieved, the dimension of transverse cut upon the square tube was remodeled to achieve threefold. This is done by adjusting the height of cut, the thickness of tubes, and others. The machine was refined once threefold is achieved for much more accurate simulation. Once threefold was achieved, the data of the model is transferred from the Abacus to MATLAB to calculate and generate energy absorption data. Lastly, expected result. An approximate model for the bending behavior of square tube which multiply transverse cut is obtained by creating it using Abacus. A refined mesh for the model was obtained before the analysis began, and threefold or point of bending were obtained using finite element analysis in Abacus after a number of process redesign of the model were completed in order to obtain threefold or point of bending using finite element analysis. When using Abacus, it is possible to generate force and displacement data and then be used in MATLAB in order to collect data on energy absorption. The data being obtained from Abacus and MATLAB will be tabulated and graphed. Table below is a sample graph for one fold. There are graphs for force versus displacement. We expected to get threefold so it can increase the efficiency absorption energy. The area under the force displacement curve equally the amount of absorbed energy. This is our project planning. That's all for me. Thanks for watching.